You might have heard about carbon dating before. And when you read up about carbon dating, you will come across carbon 14, the term carbon 14. So what is this carbon 14? What does that mean, and why do they not call it simply carbon but they call it carbon 14? Carbon 14 is one of the isotopes of carbon. Now what is an isotope? Two or more atoms with the same number of protons but different number of neutrons are known as isotopes. So 3 isotopes of carbon that are commonly known are C12, C13, C14. This is the mass number. Now, what is the atomic number? All of them are carbons, so atomic number, in other words, number of protons, is 6. And so they all have 12 minus 6 neutrons, 7 neutrons, and 8 neutrons. So they all have same number of protons but different number of neutrons. So these 3 are isotopes of carbon. These are the very commonly known isotopes of carbon. So now, which is the actual carbon? Is this the actual carbon? Or this the actual carbon? Or this the actual carbon? All of them are carbons, because remember, identity of the element is the number of protons. Right? Identity is the number of protons. So they all are carbons because they all have 6 protons each. Why are they different? They are different because they have different number of neutrons. Now, so which do we use for reactions? Should we use 12 or 13 or 14? Now remember, as far as chemical reactions are concerned, they all are same. They all have same chemical properties. So if you have a sample of carbon, say just for making it easier, 100 gram sample of carbon, out of this, some percentage will be 12, some percentage will be 13, and some percentage will be 14. So just to make it easier, let's say this one is present in, I'm using numbers here that are not right. I'm just using easy numbers, so to make it easy for you. We'll do an actual problem in a minute. So this one is, for example, say 98%. This one is 1.5%. This one is 0.5%. So all of it put together, 100. Right? This percent value is known as isotopic abundance. Isotopic abundance. Okay, now let's go to a real example. Nitrogen has 2 isotopes, nitrogen 14 and nitrogen 15, and 99.632% and 0.368% abundance. Okay. So what information will go on the periodic table? Will information for this one go on the periodic table or this one? Again, they both have same number of protons. So nitrogen has 7 protons. So that will go on the periodic table. Now, they will take the average of these 2 isotopes, the mass of weighted average mass of these 2 isotopes, and that mass will be given as the atomic mass of the element. So on your periodic table, you will see atomic mass of nitrogen as 14.01 AMU. So where did this number come from? This is a weighted average of these two isotopes. Okay, mass of the first isotope, nitrogen 14, is 14.003074. Let me use another slide to make it easier. Okay, there are two isotopes of nitrogen, nitrogen 14 with a mass of 14.003074, isotopic abundance of 99.632, and another isotope of nitrogen, which we will address as nitrogen 15, with a mass of 15.000108 and an isotopic abundance of 0.368%. Right? So how do we weight average this? First of all, these are percentages, so this will be 0.99632, so 99.632 divided by 100, and this would be 0.00368. Okay, how are we going to weight average this? 14.003074 multiplied by 0.99632 plus 15.000108 multiplied by 0.00368. Okay. So when you perform this calculation, you will get an answer of 14.007 AMU. I don't know if you've noticed this, but I have been using this unit AMU in this video quite a bit. What is this AMU? AMU is atomic mass unit. Okay, and this is a unit of mass, just like grams and kilograms, etc. It's a unit of mass. It's a very small unit. It is so small that 1 AMU is equal to 1.66 times 10 raised to negative 24 grams. So this is such a small number. It's in the order of 10 raised to negative 24 grams. So it's very small. Now why do we use such a small number? You have to remember that atoms and molecules are very, very small. Atoms are so small that units like grams and milligrams are too big for them. So you have to use a unit which is much smaller. So we use atomic mass unit which is in the range of 10 raised to negative 24 grams.